The overall goal of this procedure is to form and image capillary bridges in slit pore geometry. This is accomplished by first making long, raised PDMS pillar substrates using standard photolithographic molds. The second step is to functionalize the top of the pillars to introduce a wetting contrast between the top and the sides using imprint transfer lithography and self-assembled monolayers. Next, the two pillars are placed facing each other in a 4-axis microstage device. The translational and rotational degrees of freedom allow the investigator to properly align the two facing pillars and to control the separation between the pillars during the experiment. The final step is to introduce liquid between the two raised pillars and image the resulting capillary bridge with the CCD camera as the height of the slit pore is changed. Ultimately, the change in morphology of the liquid bridge as the slit pore height is increased is used to show that the Laplace pressure of the liquid bridge switches sign from attractive to repulsive as the slit pore height increases.
Though this method can provide insight into understanding the characteristics of partially pinned wetting phenomenon, it can also be applied to problems such as flip chip design, oil recovery in porous materials, and bio-inspired adhesion.
Prior to starting this procedure, clean a 4-inch silicon wafer with Piranha solution. Following this, spin coat SU8 2002 onto the surface of the water for 40 seconds at 500 RPM. Next, spin coat SU8 2050 onto the wafer with a 2-step spin coater program for 40 seconds at 500 RPM, followed by 1 minute at 50.